All right, we shall. We'll take a look. All right, it's Friday, end of another week. We got through the week. Okay, I want to kind of just walk through some example of doing some exploratory data analysis, and this is this is an example, but really just like working out, practicing a sport, practicing a musical instrument. The way you're going to get better is to do things yourself. Okay, so this will be an example of like something you can try out and explore, but really what you should try to do is you should take a look at a data set and try to explore it yourself. Ask questions. Say, hey, what kind of questions can I answer with this data set? Or what kind of questions can I even explore with this data set? And then try it out. And then you'll start to encounter the different kinds of problems, the different kinds of issues. And the idea is you have a good enough question where as you're trying to answer it, you get a little bit stuck, okay? If you get a little bit stuck, that's a good sign. That means your question is not trivial. That means your question requires some thinking. And this is how you're going to get stronger and get better. So I'm doing I'm like walking through an example here, but again, you're not going to get better at basketball by watching other people play basketball. You gotta try dribbling and taking shots yourself, okay? So here, the data set that we will use is the NHANES data, okay? So there is something called the National Health and Nutritional Examination Survey. This is run by the CDC. They go and they get some a selection of people and they take measurements, okay? And they do all kinds of stuff. All right, it's interesting, and they've been doing this for many years, and they'll ask different kinds of questions, and the different tables and stuff that we have. So there are different tables of information. Today we're going to take a look at this demographics table and body measurements table, okay? And this is from 2015, 2016, pre-pandemic stuff. Okay, so the demographics table has information, okay, like, so you have the respondent sequence number. This is basically an ID number of the person participating in the survey, but it's got things like the gender, age in years. If it's a child, it'll be things like age in months. And you have the kind of the data dictionary in terms of what kind of things. So age in years ranges from 0 to 79, and then 80 or older just gets listed as an 80. Okay, age in months is for 0 to 24, things like that. Racial information, different kinds of stuff, education level, marital status, citizenship status, things like that. Total number of people in the household. So this is all kind of demographic information, language of the people, household income, things like that. Okay. We also, there's different tables, okay? But I will take a look at the body measurement table, body measures table. And this will have things like the person's weight, okay? The person's height, okay? Their recumbent length, I'm not quite sure what that. I think that's like how if the person couldn't be standing or something, that how tall or how long are they if they're lying down. Standing height, things like their upper leg length, upper arm length, arm circumference. They measured all kinds of things, and all kinds of things. All right, so that's information regarding the data here. Okay, so I'm going to go ahead and load up our different packages. Sorry, I don't know what's going on with the connections here. All right, so we'll load up Pandas, NumPy, Matplotlib, Seaborn. And then I'm going to load up our data. The data comes in, the NHANES site stores the data in SAS format. So we don't really use SAS, but Pandas is able to read in SAS data. So you do that using read_SAS, okay? And so I'm going to take the body measurements table and call that BMX. The demographics table, I'm going to call it demo. And then I'm going to join the two tables using the sequence number. So we're basically going to use the patient or participant identification number, which is the sequence number, and use that to align the different rows so that all of the body measurements correspond to the correct person. So that's going to be form merged. So merge is done. Basically, you name the table. You have your left table. You got two tables, right? So you name your left table the BMX table, and then the right table. So you're going to do BMX.merge. The right table is going to be the data frame that you want to merge with. So we're going to merge the body measurement with the demographics table. And then how are you going to align them? We're going to align them on using the sequence number. Okay, so this is the resulting table. We see there's 9,544 rows, 72 columns, just the first 5 rows, last 5 rows, the first few columns. So a lot of the columns are left out, and then some of the other columns here. I can ask for some of the merged info, and it just kind of prints out information about the first, 20 columns, and then the last 2 columns. It says output is truncated. I'm going to click view as a scrollable thing, and we can get information about all 72 columns. Okay, and we can see, again, it's a little bit hard to read all of this stuff, and so this is why data dictionaries are very important, so that you can be able to read and understand what it is that you're even looking at. And I don't even know what some of these things are. Sagittal abdominal diameter. First, second, third. What is that? I'm going to look this up. See, it's always good. More actions. Oh, search. That's what we want to do. Sagittal abdominal diameter. Oh, look. Is a measure of visceral obesity, the amount of fat in the gut region. Oh, okay. Do you have a picture? Oh, this is how you do it. No, that's supine. Oh, sad. It's kind of a... All right, so anyway, apparently you measure something. What does sagittal mean? I feel like I see that word a lot. It means of or related to the suture between the parietal bones of the... Of related to the median plane of the body. Oh, look at this sagittal plane. Oh, this is the sagittal plane, the axial, transverse. Oh, frontal, no. Sagittal, okay. Oh, well, that's still the transverse, oh, whatever, all right. Sorry, sidetrack. In general, if you're encountering data that you're not super familiar with, try to learn as much as you can, okay? And then always ask yourself, so this is an important thing, okay? Especially if you're getting data from a site that is not super reliable, like Kaggle or something, right? So if you get data from the government, generally, at least the US government, you feel like it should be pretty reliable. There should be pretty good data that we can trust, okay? But then you get data from some site like Kaggle, and Kaggle is great. Some of the data sets on Kaggle are excellent, but also Kaggle is like, it's like the rest of the internet. People can upload stuff, and there's no like fact checker on Kaggle that says like, oh, this data wasn't good. And so people post random things, and sometimes their data sets are junk, okay? And so you don't ever want to go blind going into a data set and have no idea what any of these numbers mean, right? So if you see somebody upload a data set and it has like height information in there, just do a quick analysis of that column and just say like, oh, okay, I just kind of want to make sure that there's nobody in my data set that's over 10 feet tall. Because if you're encountering individuals in your data set that are over 10 feet tall, then probably something's wrong, right? So, something like that. Whereas, if you're not familiar with the data, right? If it says like, oh, here's information on like kidney patients, and it says these are numbers on, I don't know, hormone XYZ. These are the hormone XYZ levels, okay? And it says, oh, this person has a number of 853. Is that high? Is that low? You have no idea, okay? And 853 could be the equivalent of someone being 25 feet tall, where if you saw that in a regular data set, you'd say that's got to be a mistake. Okay, there's no way somebody's 25 feet tall. There's no way somebody has this hormone level of 853, okay? But if you're not familiar with that data, you would have no idea. And you would leave in the 853, and that would be, like leaving in the person that's 25 feet tall. So you want to make sure you have some familiarity with these numbers so you can say, hey, you know what, this number just doesn't make sense, okay? Right? Like if you had like pregnancy information and they had like, okay, age of, time of gestation, right? Like how many weeks? And you would expect most of the things to be, I don't know, 38 weeks, 40 weeks, something around there, okay? Something around 9 months of pregnancy, okay? And sometimes it'll be shorter because sometimes babies are born premature. Sometimes it's going to be a little bit longer. But if you see something in there that's like 52 weeks, right? The equivalent of being pregnant for 12 months, we know that's not like possible, or like this would be, I don't know what the world record is for longest pregnancy, but it's not going to be that. And you would have to clean up your data set like that, right? And if you don't have a base familiarity with the data, then those types of glaring values you will not notice, and so it's very dangerous, okay? So always you want to have some base level familiarity so you can say, hey, this number doesn't make sense, okay? Or if I'm encountering this number, why am I encountering it, okay? So anyway, that's what we have, right? And these things, I have no idea. What is it? WTINT 2YR? You got to go to your data set. But I mean, this is, again, we have, this is coming from the US government, or the CDC, so we feel like it's pretty full sample 2-year interview weight. Okay. All right, I don't know what that means. How is it coded? It's coded as something. Okay, so I don't quite know what these things are, but whatever. I'm not using that variable, so I'm not going to worry about it. Let me close out this thing. So, but we feel like CDC data is going to be pretty accurate, so we won't worry. But again, just in general, if you're working with a data set that you got off the internet, do kind of a sanity check and just go through the different columns and things like that, okay? So here I wanted to do this analysis and just kind of ask this question of like, do baby boys weigh more than baby girls on average? So in our data set, we have adults and children and babies. And, in general, adult men, on average, weigh more than adult women. But the question is, what about for babies? Is there a difference there? Okay, and so, as far as our data set goes, the relevant variables would be the gender of the baby, the weight of the baby, and then also the age of the baby, because obviously a 5-month-old baby is going to weigh more than a 3-month-old baby. So if you're going to compare baby weights, you want to compare 5 months old with other 5 months olds and things like that. So these would be kind of the 3 variables that would be relevant. And so here I'm going to do this. Okay, so what I'm going to do is I'm going to take our data set and I'm going to select basically all of the rows where the age is less than or equal to 12 months. Age in months is less than or equal to 12, so that will be all babies from 0 to 12 months. Okay, and so I'm going to say, so I'm going to do merged dot location. This will pick out basically a subset of the thing, and then we're going to say we want where this column merge dot age in months is less than or equal to 12. Those rows give me all of the columns. Okay, and then I want to make a copy. Okay, because if you don't do a copy, .loc generally gives you a view object of the original thing. So here we want to kind of get a subset, a copy that we can kind of work with. So this is what we're going to get. And when we do that, I get 399 observations, 399 rows. Okay, and then what I want to do, if you take a look at babies in okay, so these are all floats, okay, and we're gonna I'm gonna just convert them into to integers. Okay, so I'm gonna create a column just called age. So I'm gonna do babies. I'm gonna make a new column, okay, age, and then we're gonna just take age in months and do as an integer. Okay, so I do that. And then I'm going to subset to just the boys. Okay, so I'm going to do babies.location where gender is equal to 1, because that is how they coded the. So boys are coded as code 1, girls are coded as code 2, or that's what we have. So we'll do that. So our baby boys are there. So we have 192 baby boys. And I'm going to group by that age column. I'm going to do baby boy group by age column, and then we're going to select the weight, and we're going to calculate the mean. Okay, and so when I do that, I get age 0, 1, 2, 3, up to age 10, and this is going to be their weight. Okay, so at age 0, I think weight is in kilograms, but I will just. Yeah, weight is measured in kilograms, so that's what we have. Okay, so at age 0, 4.79 kilograms, age 1, 5.79, so on and so forth. Okay, we'll do the same thing. I'm going to do basically the same lines of code, except gender is equal to 2, and that will be for the girls. So I'm going to just run the same thing, 207 girls. And these are the values that we have, okay? And then, and to just kind of get a visualization of this, I want to calculate, okay, what is the difference between the boy weights and the girl weights, okay? The difference between means. And what we see is that the boy weights are minus the girl weights, they're all positive. So at least in our data set, they're all, the boys weighed more than the girls. And then here I'm going to create a data frame. One column will be for boys, one column will be for girls. We're going to take the boy weights by month, girl weights by month, and then we'll take set the index to be an integer, and then I'm just going to create a plot. And this is the resulting plot. Okay, so in our data set, we would have expected kind of a constant increase, but just because of kind of randomness, sometimes we have these dips where, like, the 6-month-old babies happen to weigh a little bit less than the 5-month-old babies. And, so if we looked at individuals, probably they keep going up, but just when in our random sample, I don't know how many 5-month-old babies we had and how many 6-month-old babies we had, but just in our random sample, the 6-month-old baby boys happen to weigh on average just a tiny bit less than the 5-month-old baby boys. So, but overall, what we do see, at least in our data set, is that across all ages, the average weight of the baby boys was higher than the average weight of the baby girls at the same kind of age, right? So at least in this data, it does seem that on average, baby boys weigh more than baby girls, okay? So that's interesting, and that's what we have written there, right? So this is just kind of, just a question that I had that I was wondering about, because I have 2 girls, and then my sister has 2 boys, and they're all around the same age, but like her boys are just much kind of more, I don't know, they're bigger. And I was just like, oh, I wonder if that's like just happens to be the case in with these children, or if this is like a general trend. So I just wanted to kind of take a look at the data and explore this. So that's what we have. Okay. And yeah, so there's lots of kinds of questions you can explore. Here's another question. Okay. So is there a relationship between height, leg length, and arm length? So this is, in general, we think if you're taller, you're going to have longer legs and longer arms. But sometimes you'll have these basketball players who are already tall, but then their arms are even longer, right? Like if you think of some basketball players who are like excellent defenders and have like huge steal numbers, like they're able to kind of like steal the ball from the other players and stuff. It's like their arms are unusually long. So like the basketball player is tall to begin with, and then you'd expect them to have long arms, and they do have long arms, but they're even longer than one might expect or something. Okay, and then I think there's also kind of this known phenomenon that as people age, especially when they get really old, their stature shrinks a little bit, and there's all kinds of different things there. And I was just kind of curious, like, okay, how does this work? So again, a question, and then just kind of starting to explore. And so here, I'm going to look at these measurements. The height, you have leg length and arm length. And you can look up more information for each of these variables. Okay, so here it is for standing height and arm length, upper arm length, and so on and so forth, measured in centimeters and whatnot. Okay, so here I'm going to just filter to adults. Okay, and so arbitrarily I just chose people aged 20 and up, and I just wanted to see how this is going to work. So I'm going to select all of the rows, but I'm going to select the columns, height, leg length, arm length, and then age in years. I'm going to create a copy of that and call that thing limbs. I'm going to drop anything that has missing values. So I'm going to do drop NA, and then I'm going to filter to where age in years is greater than or equal to 20. And just again, arbitrary number that I've selected, and we'll do that. Okay, and so when we do that, I have a total of 5,086 rows in my data. Okay, and so here are we can just kind of take a look at some of these things. I can just so we see height in centimeters, 184 centimeters. So that's over 6 feet tall. And this is their leg length, 43.3, arm length, 43.6, age in years, 62. everything's in centimeters, and it's just like, I don't think in centimeters, so I don't know how long like 43 centimeters is, right? It's like 1.5 ish. Is that long? I have no idea. I have no idea. Like if you were to measure these things, I don't know. But okay. So what's the correlation? Is there a correlation between these things? And we see, yeah, there's positive correlation. Okay, height and leg length, 0.787. Height and arm length, 0.797. Arm length and leg length, correlation of 0.629. So positive correlation of around 0.8-ish and whatnot. Okay. Here, what I want to do, so if you look at the ages, we have things like 24, 35, 80, 26, 76, and things like that. I just thought it might be useful to group them by decade. So rather than just having like, this is the average height of 24-year-olds and the average height of 25-year-olds, just because your groups would be kind of too big to make any kind of reasonable thing, or too small to have any kind of reasonable trends out of them. We're going to establish some cuts here. So here I'm going to use pandas.cut, right? So again, there are lots of functions. There's too many functions. I can't teach every single function in pandas to you. So get used to like looking up, like I want to do this. What is the relevant function I need to do? And then read the documentation, okay? And so this is where the internet and even like AI tools can be helpful. You can say, hey, what kind of function in pandas can I use to achieve this thing? And they'll say, hey, you can achieve it using this and this. I'll probably give you some sample code. Don't just read the AI output, okay? But also go to the documentation and read it in detail. You will get much more out of it by reading the actual documentation, okay? So anyway, what I'm going to do is I'm going to create cuts, create little bins, and I'm going to create age groups based on the age in years, and the bins will be go from 20, by groups of 10. So my age groups. So now I've done this based on that, and so this person who was age 62 gets put in the 60 to 70 or 60 to 69.9 bin. This person who's 53 and that person who's 78 goes into their respective bins, 50 and 70 and so on and so forth. And that's what we have. Okay, so let's go ahead and I'm going to take this column, add it to the age groups. All right. And so now this is what I have, and this looks correct. All right, this looks like the age category has been done correctly. Okay, and then and now I'm going to group by the age category, and I'm going to calculate the mean for each of these values. Okay, and we're going to just do it for the height, leg length, and arm length. Okay, so when I do that. Now that I've created by groups, these are the different groups. These are the heights, the leg length, and the arm length. It's a little hard to read, but let's go ahead and take a look at how this has been affected. Now, in order to kind of, so I could try doing summary.plot, and that looks fine. Just to kind of make the horizontal axis look a little bit easier, or easier for me to read, I'm going to just replace, it goes 20, 30, 30, 40, so on and so forth. I'm just going to replace it with 20, 30, 40, so on and so forth. So this is now going to be my, I'm going to have that, and then I'm going to just create a plot. Okay, so this is the result, and it's a little hard to see because the highest over here is like 167 and the lowest over here is around 162. And then as far as leg length, the highest over here is, I don't know, 40.06 and the lowest is 36. So it's hard to see like, okay, is there a huge trend or not? So what I'm going to do is just kind of arbitrarily, I'm going to subtract off. So here I got 167.87 and 40. I'm going to just subtract off 128 off of all of these numbers, so they're on the similar scale. So it's not 40 and 168 or whatever. So I'm going to create another column called adjusted height. I'm going to just take the current height, our summary height values, and subtract off 128. And then I'm going to create a plot using this, okay? And this is kind of revealing, all right? So what we see is that, so if I just, all I did was I just slid the blue line down 128 units, and then I plotted it. And what we see is that as people get older, at least in our data, the leg length gets shorter. And I didn't know this was a thing. It's like, is my leg getting shorter? I don't know. I never thought of like, where did the table go? But it feels kind of strange. But apparently, at least in the data that we've recorded here, let me go here. Okay, upper leg length. So it feels, is that even possible for your upper leg length to shrink? I'm curious now. But it does seem like over time that thing gets shorter. Okay, the height also goes down, and but then after age 70 to 80, there's like a huge drop in height. Okay, and then arm length, however, that like stays about pretty flat over time. Okay, so that's I don't know. Does upper leg length decrease with age? Does not change length. All right. The long bones of arms and legs are more brittle, but they do not change length. Okay. Well, I don't know, because I'm looking at this data and it sure looks like it's getting shorter over age. But maybe there's something else going on. Maybe the older people got less nutrition, so they're. But this is like way too linear and way too. I don't know. Okay, maybe it's just a coincidence of the data. Okay, but anyway, it does seem like something is going on there. Okay. This was another question. All right, is there a relationship between height or weight and income? Right, like. Sometimes you hear things about oh man. Okay. Basically to eat healthy, like it costs more money to buy healthy foods and to buy, there's now an abundance of lower quality, high calorie foods, and so perhaps there's a relationship between weight and income. Okay, is there a relationship between height and income? I don't know. So I just thought, well, let's take a look. And so we have and there's a couple things. I decided to use household income as the demographic, but again, just questions, any kind of questions you can try to start exploring. I have forgotten about our view quiz answers, haven't I? Have I given you any of them? None. Okay. Let me look. Week 6, Friday. Okay. I'll give you your first two. First two are the letters C and B. C and B. C as in cat, B as in bear, for your first two answers for today. Okay, is there a relationship between height or weight? So again, I'm gonna just kind of subset to the relevant variables: BMX height, body measurement weight, household income. I'm gonna do age in years. Drop missing values. Again, just kind of arbitrarily, we just want to kind of look at adults. Okay. All right, so I'm going to create groups based on household income. And Household income, if you look at the data, it is, the categories are a little bit wonky, okay? So annual household income, and you have 0 to basically $49.99, 5 to $9.99, 10 to $14.99, so on and so forth. And then category 10 is 65 to 75,000. And then category 12 and 13 are a little bit odd. It's either 20,000 and under, 20,000 and over, or under 20,000. And apparently these are all mutually exclusive. So I don't know how this works. These people got different questions, because 20,000 and over, like any of these would have also said yes to this, but apparently they got different questions. So when we do this, I'm going to just eliminate categories 12 and 13, because I don't think it makes sense to include this with everyone else, all right? And then category 14 is 75 to 99,000. Category 15 is 100,000 and over. And then we have refuse to answer, don't know, or missing. So I'm going to get rid of basically these numbers and these numbers. So these are household income. Okay, and then you have similar things for family income. I'm not 100% sure what the difference is between family income and household income. I don't know how we define these things. But anyway, I have these different categories. So just this is you group by that category, household income, and then I'm going to just get rid of categories 12 and 13 and 77 and 99. So I'm going to subset using this, and we're going to do weight. Household income is in. This is kind of a stupid way to do it, but I did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 14 and 15. And then I want to create a plot of that. So this is the plot of weight by household income. And it kind of just bounces around, so I don't see a very strong trend here, okay? But I do it for height, okay, BMX height. And interestingly, there does seem to be a trend, okay? And again, how strong is this trend? I don't know, but it does seem like there is some kind of relationship that higher household income, taller people, so maybe, and we're not saying, again, you got to be careful. No, don't draw cause and effect conclusions, okay? But, are taller people more likely to earn more money? Or does earning more money make you more likely to be taller? I don't know, okay? But this is interesting, right? This is interesting that there is some kind of relationship here between height and income. Weight and income doesn't seem, this seems a little bit flatter. I don't know. Okay, but these are kind of interesting things. And so these were just some of the questions. Okay, again, you have a question, you just start exploring, and you try to find the relevant kind of columns and things to start answering them. So I want to encourage you to. And I think the NHANES data set is an interesting data set, and there's tons of questions you can ask and start to explore. But there's other data sets out there that you can explore as well. DataCamp, so you have access to DataCamp. They have a little section in DataCamp that I think are called projects, and they have kind of like little guided. They have a data set, and then they have some questions that will kind of guide you towards exploration, okay? And they're a little bit more open-ended. So a lot of the chapters that I assign in homework, they're very kind of hand-holdy, right? They give you a lot of like things, and you just kind of fill in like a few blanks and stuff. And so if you want something a little bit more open-ended, the DataCamp projects are a little bit more open-ended. And then, when you are faced with kind of these open-ended things, then you realize it starts to reveal the gaps in your knowledge. And that's a good thing, okay? It's a good thing when you go, oh, actually, I don't even know how to get started. And you start exploring and start answering questions there. Okay, that's all I have for today. Let me give you your third view quiz answer, which is the letter A. A as in apple. And we'll wrap things up here. Have a good weekend. Monday is a holiday, Veterans Day, and we'll see you on Wednesday.